For our next piece about the particle in a box, we're going to talk about the allowed energies. Now we saw in the previous video that the solutions to the Schrodinger equation for the particle in a box is psi n b sine n pi x over a, where n is a positive integer. The value k had a value of n pi over a, but we also showed earlier that k was equal to 2me over h bar. Well, let's solve for e. So I'm going to square both sides. N squared pi squared over a squared is equal to 2me over h bar squared. H bar squared, n squared, pi squared over 2ma squared is equal to the energy. And furthermore, since h bar is 2 pi over h, I think I messed that one up. Okay, h bar is h over 2 pi. So when I work this in together, I put these together and I get E is equal to n squared h squared over 8ma squared. What do we see here? We see that the energy levels go as n squared, where n equals 1, 2, 3, etc. We see that the energy level separations get smaller with increasing mass, and they get larger, and it's also smaller with an increasing size of the box. Let's draw a diagram. So first off, we have at n equals 1, my energy is equal to h squared over 8ma squared. That's not zero. This is important to note. The energy is not zero for the lowest energy state. For n equals 2, it's going to be 2 times 4, so equal to 4h squared over 8ma squared. So 1, 2, 3, so n equals 2. My next energy level, n equals 3, is going to be 9h squared over 8ma squared. So this is 4, 8, about 9 right here, and so on. And what we can see is that the energy levels for the particle in box go as the square of the quantum number, where n goes from n equals 1 to infinity. There's no upper bounds on the energy for the particle in box.